So let's talk about a fairly advanced or intermediate topic in programming that's called a design pattern. What is a design pattern? Well, a design pattern is a reusable, general solution to a commonly occurring problem in software design. They're inspired by patterns that are found in real-world architecture and are applicable in non-game software as well. Basically, when you're developing a game or an app or a piece of software, you often run into the similar kinds of problems. And a design pattern is a way to address or solve those problems. They're common practical solutions, as in they address some sort of common game development challenge in this case, such as for interactions or performance. And there are solutions that have worked in the past. You would find that a lot of games share the same kind of structure because, well, design patterns are a way to address the problems you run into, and then you get a lot of perks that come from it. And plus, they're reusable. You don't reinvent the wheel. You can just take the basic premise or the basic idea and implement it yourself. You're not coming up with a brand new solution to a problem. You also get some improved communication because you don't have to break down a unique individual structure. You can say, oh, hey, we implemented a state machine here. And if you know what a state machine is, then you know what we're talking about. They also tend to facilitate easier changes or flexibility, which is usually the problem that is being solved. How do you take a small game that works now, but when you add in additional features or additional power-ups or additional levels or more players, is it scalable? Well, design patterns tend to be a solution to those problems. Well, it'll make it scalable if you develop and build things the right way. They're also adaptable. The core principles remain timeless. They work kind of no matter what, from games way back in the day in the 80s to now. You'll end up having the same basic design patterns because you kind of always run into those problems. Now, there are a bunch of common game design patterns, but 4 really common ones that you kind of encounter all the time are going to be state machines, singletons, the observer pattern, and pooling. Now, the book that I'm pulling this from is Game Programming Patterns by Robert Nystrom. This is easily the best book that I've ever found on the subject. It's short, concise, and practical. It talks about things in examples that apply to kind of any games, or at least easy to wrap your head around. It also has the single best back cover of any book ever that I just find that personally hilarious. I love it. The book is available actually online for free, I believe, but there are a ton of copies and it's fairly cheap on Amazon as well. So I highly recommend taking a look at it if you're interested. So let's talk about the first of the design patterns that I think most people end up interacting with fairly early on in the game dev experience, which is the state machine. Here's a scenario. You're making a game and your main character of that game is a robot. In your game, the robot can move left and right, they can jump, they can climb walls, and they can attack. You built in the ability to move left and right, and you've built in jump. Well, if you don't do it right, then you can make it so that the robot can double jump or triple jump. Or you can make it so they can move left and right while climbing a wall. And things can get a little messy. In this game specifically, you shouldn't be able to attack while you're jumping. If the character jumps, they should not be able to attack. You also shouldn't be able to attack while climbing a wall. You also shouldn't be able to climb a wall if you're not jumping. How do you easily define the behavior so that way you can do certain things or can't do certain things while another thing is happening? Well, what you do is you break down the abilities or the states that the player can be in, specifically a finite state machine. Now, the state design pattern is a fixed set of states that an object can be in. And fixed means you define it for the game. You define what the states can be. Now, your state machine can only be in one state at a given time. You can only ever be idle or jump or moving. You can't be in different states. And you transition between these states based on an input or events. Now, if you've done any work in animation inside of Unity or Unreal Engine or any other game engine, really, there's a good chance you've seen this. This should seem familiar because animations tend to be handled using a state machine. Now, your robot character gets certain states. They have an idle state, a walking state, a jumping state, climbing state, and attacking state. And in those states, you can transition between those different states depending on certain criteria. So for instance, if your robot is an idle state, as in they're just standing there, they can transition from idle to walk or to jump or to attack based on player input. But they can't climb a wall because they're idling. So you don't build a connection for you to be able to transition between the idle and climb. You build a connection to transition between idle and attack, idle walk, and idle jump. Now let's say the player pressed the jump button. You transition your state machine from idle to jump, where jump is your current active state. And in this state, then they can't attack. They also can't walk. They can only go to idle or go to climb. Set the transitions and how it should transition to limit the behavior or to expand the behavior, depending on what you're trying to do, of your character and player. Now, this example is in Unity. However, this applies to other game engines as well. Here we have an animation. We have our entry node where we go from entry into idle. This idle node right here, this is a state. We can be in the idle state. And we have transitions where we can go from idle to run based on certain conditions. And we can go from run back to idle based on other conditions. We can also transition from idle to jump and from jump to fall. So these are different states that the player can be in. Now, if I press play, I can see that my character is currently in the idle state. I can tell because there's this blue bar that's playing the animation. But if I jump, I transitioned into the jump state and then into the fall state afterwards. I'll do that again. So now I'm in the jump state. The animation changed. And once it started falling, I switch to the fall state. If I move right, I go to run state. Same with left. Now I transition between these different states, and then I can define my behavior. Now you can implement this in code as well, not just through animation sequencer like this. You can actually define it in your code as well, and you can say, if player is in state idle, what can they do? What can't they do? Things like that.